Relations and functions may sound similar. However, here are two big ideas to keep in mind as we go through the lesson today. So one, let me underline in a different color. Not all relations are functions. However, all functions are relations. Just keep that in mind as we go. I'll explain more why as we go deeper into the video. So first, to start off with some definitions. What is an input, an output, domain, range, relation, and function? It might sound overwhelming at first, but we'll go deeper into it with like the algebra, graphs, tables. It'll make a lot more sense in a minute. So when you think of relations and functions, you're usually talking about many x and y pairings. And essentially what an input is an x value. At least for the purposes of today, it's just an x value. And the output is the y value. And domain and range are essentially just sets of those. So we can say a domain is the set of all x values. And as we've already said, input is the same as the x value. So we can say for inputs, range corresponds with y. So we can say the range is the set of all y values or outputs. And then here's the main question, which we'll continue to answer throughout the rest of this video. Relation and function. So a relation is just a set of ordered pairs. In case you aren't sure what an ordered pair is, this is what an ordered pair is, just an x, or basically an input, and an output combined together. A function is essentially a special type of relation. So a function is a relation, and here's the distinction, where every input has only one output. All right, and if this function definition compared to a relation seems a little confusing, no worries. Let's take a look at it in some actual problems. Okay, so let's take a look at this left relation right here. So in accordance to a relation, we have a set of three ordered pairs, or it doesn't have to be three, but in this case, we do have three. We have the point 1, 3, 3, 0, or no, 3, 0 rather, and 5, 2. So let's try to show this in these big circles right here. And just to kind of clarify once more, remember x, y, that is a coordinate point, that is an ordered pair, and that's exactly what we have in these three. So with these circles, which I'm going to move down a little bit, let's call them by domain and range because we want to separate, at least for the purposes of this, we want to separate the x values and the y values, the inputs and the outputs. Because we want to determine if this is a function or merely a relation. Domain, and here we have range. So let's just remember all x's and range is all y's. So let's kind of look at what we have in our relation and let's write it in. So we have 1, 3, and 5 for x values. 1, 3, 5. And then let's look at our y values, or everything within our range. We have 3, 0, and 2. 3, 0, and 2. Now, if you take a look at this, each input, well, in this particular case, each input has one output. One goes with 3, 3 goes with 0, and 5 goes with 2. And why is this a function? Why is this relation a function? So each of these x values, each of these inputs that I've just circled right here, they do not have differing y values or differing outputs. And then we can show that again with domain and range on the bottom. But essentially, we don't have, let's say, this value, x equals 1. We don't have this value giving us two different y values or two different outputs. If it did, that would not be a function. But since it doesn't, it is a function. Let's look a little deeper by showing domain and range. So remember, domain is just all possible x values. Range is just all possible y values. And these notations that I've just circled are essentially the same thing as what we drew in these bubbles, just a little different. So we can write the same things, 1, 3, 5 as all our possible x values. And the range we have 3, 0, 2. And technically these could be in order. So let's write it ascending. So 0, 2, 3. And just as we did by drawing arrows to show that it's a function, we can do the same here. So 1 goes with 3, 3 goes with 0, and 5 goes with 2. And how did we get that? We looked at this relation up here with these coordinate points. And just as with our two big bubbles with the domain and range up here, we got the same result. We don't have inputs that yield multiple outputs. We don't have, like, for example, 3, it doesn't yield two different outputs, two different y values. We can even show it in a table where we have x and y, 1, 3, 5, and these have to be ordered because each x value corresponds to a specific y value. So we have 1, 3, 3, 0, 5, 2. And same here, we do not see repeat x values, like we saw 1 again and they gave us 7. That would just be a relation that's not functional. But since we don't have that, this is a function. Now let's look at the right problem. So we can draw in our table again. So we have domain, which we know is all x values, and range, which is all y values. Now let's write it in here. So we have 3, 4, and 5 as all our possible x values. 3, 4, and 5. We don't have to write 4 again for this kind of example. Then for our possible y values, we have 7, 2, 3, 0. 7, 2, 3, and 0. Now, let's draw some arrows. So I'll use red. So 3 goes with 7, 4 goes with 2, and 4 goes with 0, and 5 goes with 3. Because of this 4 right here, which I will actually circle to make it a little easier. 4, oh, it's kind of good. 4. Because that x value brought in two different y values, this is not a function. This relation is not a function. And here's how we can model it in a table. We have x, y. So we have 3, 4, 4 again, 5. We can write it in. 3 is 7. 4, this first 4 can be any of these pairs. Doesn't necessarily matter which. I'll write 0 and then 2. And then 5 corresponds to a y value of 3. Because we see 4 repeated in this table, providing two different y values, this further shows us that this is not a function. Same thing with the domain. If it's not clear already, So I got 3, 4, and 5 from this domain thing, but if you were just looking at a set of or a relation of ordered pairs, you can see we got 3, 4, and 5. The reason I'm not writing 4 twice is because it's repeated. It's already clear, it'll just be redundant. Let's reduce 5. Then the range, just accordance with that, is 7, 2, 3, and 0. And we'll draw our little lines again. 3 goes with 7, 4 goes with 2, which I'll use a different color. 5 goes with 3, and 4 also goes with 0. And shown again, because of this 4, this x value that has two different outputs, two different y values, once again, not a function. Now you might be wondering, how does this look on a graph? How can we show that a relation on a graph is or isn't a function? And now I'll just plot some points. So I'll just underline the colors of each one just to show. So 1, 3. Let's plot it down here. So our x value is 1 because this is the x, this is the y. So remember, our input is 1, our output is 3. Draw a little dot right there. And then our next one, for our red underline, we have the point 3, 0. So the x value is 3, because recall it goes xy. So our x value is 3, and our y value is 0. So it'll be right there. Last but not least, we have 5, 2. So our x value is 5, and our y value is 2, so it'll be just about there. Right. So now we see that we do not have, as said before, we do not have one x value that yields two different y values. And how can we test this on a graph? Well, we do something called the vertical line test. I'll write it in. Vertical line, fix the A, line test, which will essentially just show us just that. So we put a vertical line, so let's say we have any graph, and we put a vertical line straight through it. Actually, that's a little confusing. But let's say we put a vertical line through any point on the graph throughout any point. For it to be a function, we cannot have one x value have repeat y values, or one input have repeat outputs, or two different outputs, rather. Not necessarily repeat, but two different outputs for the same input. So let's draw a vertical line. If we draw one right here, we're only touching one point. So far we're a function. We draw one to this value. We still have only touched one point. We're still a function. Draw through this point, and we're still a function. So that is graphically why this is a function. So now let's take a look at our red example. So now let's plot our points again. I will also do the same thing with the underlining just to make it the most easy. All right, so we have the point 3, 7. Sorry, x value is 3, y value is 7, just right there. Next we have 4, 2, so x value is 4, y value is 2, right there. Next we have 5, 3, x value is 5, y value is 3. And you might already know this. And then the last point, the green one, we have 4, 0. So x value is 4, y value is 0. So in order to find out if this relation, this set of, or like this relation is a function, let's use our vertical line test. So let's put it through this point right here. I know that's not perfect, but so far we are a function. Let's put it through this point. Oh, now we have an issue. These 2 points at x equals 4, we have two different y values. This red dot is at y equals 2, and this other green dot is at y equals 0. But it's the same input, meaning we have not passed the vertical line test. Even though we pass it on this point, and technically on this point as well, just because of y or x equals 4, where we have those two different y values, we're not a function. Not a function. So if you've noticed the difference, on the left example, we only have one part of our graph, one point on our graph that touches the line, or that touches the vertical line test, which makes us a function. On this one, we have two, or at least two. And that's essentially the definition of the vertical line test. So I'll just write that in. If two or more points intersect, or we could just say touch to make it simpler here, touch the line that we are testing with, like that vertical line. So let's actually specify the vertical line. The relation is not a function. And as we've seen here, we have two or more points touching. It doesn't matter if there's three, if there's 4 points along here. As long as we have 2 points that are touching along our vertical line test, we're not a function. But if we just have just one or none, that's fine. Just one, we are a function. Now let's look at some practice. So here we're trying to figure out if the following relation is a function. And we have 5 different ordered pairs. So we can do this many ways. We can do it on the graph like we just did less than a minute ago. We could also do it through our table. We can use our circles. Any method works totally fine. But for here, I'm going to use a table and then we're going to graph it just to show the vertical line test and to kind of connect the dots. Because the circle method and table, and when you have domain and range and just drawing a bunch of lines, they're all very similar. So for now, I'll just use the table because I think it's the best method to do it. So remember, we have, I'm going to draw them in a blue color, X and Y, and that's what every pair is. So we can draw this table with the input of being X and the output being Y. So now let's just fill it in. And for the X values, I'm going to do it ascending. So as we get greater in value, the Y value, however, will not be that way because they're all ordered pairs, meaning they have to go to like together. So this value 1, 1, it has to be next to each other because that is essentially a point on the graph. Okay, 1, 1, or actually, let's start with -1. -1, 1, which is over here. Then we have 0.5, 0.25. And then we have 1, 1, 1, 1, 2, 4, 2, 4, and 3, 9. 3, 9. So let me move this down a little bit just to make it a little easier to separate. Now let's draw a graph. Okay, so now let's just plot our points. So I'm going to do them all in the blue color. Or yeah, I'll do it all in the blue color. So our first is -1, 1. So we got -1, 1, which is right here. Then we have -5, or no, I'm sorry. We have 0.5 and 0.25, which, although not perfect, but it'll probably be somewhere right here. And then we have 1, 1. You can draw right here. Then we have 2, 4, 2, 4, then we have 3, 9. 3, 9. Perfect. So we've plotted our relation. So first, let's look at the table. If you notice, we don't see any repeat x values that give us a different y value. For example, if we look at this -1, we don't see -1 again that yields, let's say, 2. Like we just don't see it. That's a good way to determine if a relation is a function when you see a table. Often, when you see the same x value twice, you're already likely leaning towards not a function. But if it has a different y value for each one, as I just mentioned, if we had -1 and another y value 2, we know that's not a function. So since we don't see any repeats, we're likely to assume, and we can say, this is a function. Now, how do we look at this on the graph? Let's use our vertical line test, which I'll write it once more. Vertical line test. So let's do it through each and every point. So let's do it at x equals -1. That is not a perfect line. I'm not perfect. All right. Looks like at x equals -1, we are a function. Let's do it at 0.5. All right, still a function because so far, for every line we've drawn, we've only passed through one point, not two or more like the definition. Let me draw another point at 1. Still good. Another point at 2, or x equals 2. Still looking like a function. And we'll draw a point at x equals 3. Perfect. Since we only passed through one y value along every vertical line we drew, which is essentially x equals the numbers, like x equals 3 for that line, x equals 2, and so on. But I'm not here to confuse you. But essentially, since we've passed 0 or 1 point for every line, in fact, we don't have any repeats, like this -1 value doesn't have a point up here, point up here. It doesn't. So from the graph in the vertical line test, which we have passed, we can say this is a function. Perfect. All right, let's take a look at another problem. Is the following relation a function? So same problem, just different numbers. In fact, let's get around here. So let's do the same thing. Let's use a table and let's look at it through the graph. X and Y for our table. Just remember X, Y, that is our coordinate ordered pair. Same thing. So we can do it in ascending order just as we just did. So it looks like our lowest X value in this relation is 0. And then we have 1. So I'll actually just keep underlining to show you. 1, or let me order just the X. 1, then we have 2 2's. So automatically that's kind of tipping us off that this is likely not a function. Let's draw those in. And then we have a 3. 3. Now let's do our Y values, which I'll do in blue. So we have at x equals 0, the Y value is 5, where the output is 5. At 1, right here, at x equals 1, our Y value is 3. At, see, we have two x equals 2's, which I'll write in either. Doesn't matter which one you put in which order. But one of them equals 4, or the Y value at that x equals 2, one equals 4. The other one is -2. So let's just write those in. In no particular order, it could be like this, as I just wrote. You can also write it this way. Either is fine, doesn't matter. And then at x equals 3, our y is 2. 2. Now, just as I said, we just saw repeat x values or repeat inputs. So we're already kind of weary that this is probably not a function. So let's look at those x values specifically in our table. As we see two different outputs for that same input. As a result, we can say this is not a function. Let's take a look on a graph. So now let's just draw our points out, and I'll do it all in blue, just as the last example. There we go. So we have the point 0, 5. So x value is 0, y value is 5. So right there. Then we have 1, 3, x value is 1, y value is 3. Then we have the next value, which is 2, 4. X value is 2, y value is 4. The next value is x value is 2, y value is -2. And if you're already starting to see, we know this is probably, well, this will not pass our vertical line test. And we'll just demonstrate it just to further elaborate. Next value is 3, 2. So we have x value of 3, y value of 2. Boom. Now we have our graph. Now let's do everyone's favorite, the vertical line test. That looks a little funny. There we go. So let's do it, starting from x equals 0. All right. We only passed 1 point, so it looks like so far we're functional. All right. We also only passed 1 point. Looking pretty good. Now let's do through x equals 2. Oh, that's a problem. That is no longer a function because we passed 2 or more points aligned with the definition. In fact, let's just revisit it. Remember, the vertical line test states that if 2 or more points touch the vertical line, the relation is not a function. And as we see, 2 or more points, let's go back to our example. There we go. 2 or more points have passed our line, meaning we're not a function. I don't even have to do the rest of it. I know this is not as as uh, as consistent with our table. This is not a function. And we can even do our x equals 3, but even though that if we just looked at that x equals 3, that part passes the vertical line test, but this entire relation does not, meaning we are not a function. All right. So now let's take the knowledge and skills that we've learned to do algebraic relations and figure out if this is a function or merely just a relation that is not a function. So here we have to prove that y squared equals x is not a function, not a function. Well, y equals x squared is. So let's do y equals x squared first. Y equals x squared. Let's do a table for this, just as we have it. So x is input, y is output. So let's plug in values. So let's do x equals, let's do -2 to 2. So our domain is from -2 to 2. So we have x equals -2. If we plug that in, which we can do down here, y, when x is -2, is going to be -2 times or squared, which equals 4. Next, we can do -1. Y, when x is -1, we can just plug it in. -1 squared equals 1. Then 0, plug it in for input. Output is 0. 1, plug in 1 equals 1. 2, plug in 2 for x value for input. 2 squared is 4. 2 times 2 is 4. All right. So let's try to determine if this is a function or not. So one, I don't see any repeat x values. They all look unique to me, which means we are a function, or at least in this case, because we don't see any values along what we've plotted where we get different y values for the same x value, which means that we're consistent with our definition of what a function is, of it being a special relation, where each input has only one output, which we see in this table. Now, how does that look on a graph? We basically just be passing the vertical line test. So x equals -2, y equals 4. So x equals -2, y equals 4 right there. And then I'll just basically go down the table. At x equals -1, y equals 1. At x equals 0, y is 0. And then at x equals 1, it's 1 again. And at x equals 2, y is 4. Or output for that input is 4. Now here's an important distinction. If we do our vertical line test, which I will do quickly, we notice that we aren't getting two of the same input, two of the same x value, for a different y value. So we do pass the vertical line test. We already kind of assumed, based off this table, that we would pass the vertical line test. Oh, that is not how you spell vertical. Vertical line test, and we passed it. Remember, this is your best friend. Although we have the same y value for different x values, we're still a function. Why is that? Well, if we take a look, we're still passing the vertical line test. So here's the important distinction. Remember, it's not horizontal line test. We can have the same y value, we can have the same y values for different x values, such as x equals -2 and x equals 2. We have the same y value, but we can still be a function. So that's an important takeaway from today's lesson. All right, so now let's do the same. Let's take a look at this somewhat looking similar function, y squared equals x. So for this, I'm just going to do a table just as well, x and y. And I'm going to show you why for this function in particular, it's not going to look as similar in terms of the table. 0 and 4. So when x is 0, so let's actually just plug this in algebraically. Let's say y squared equals, when x is 0, let's take the square root of both sides. Y is also 0. Okay, perfect. Now, let's do when x is 4. So let's do y squared. Let's erase this. Or actually, I'll keep it. Let's do y squared when x is 4. So right here. Now we're going to do the same thing, but we're just going to do the square root. Square root, perfect. And here's the thing I actually forgot on the top. We're supposed to have plus and minus. And here's going to be the issue. We'll have plus and minus. Because it's a function, you're going to need that plus and minus. You're going to need both the positive and the negative value when you're taking the square root, just like that. So now we have y squared, the square root of y squared, which is y, equals plus or minus the square root of 4, which is 2, because 2 times 2 is 4. 2. Here's our issue. Now in our table, when x equals 4, we have y equals -2 and 2, because this is just, in case this is unfamiliar, this is plus 2 and -2. Completely different values. So we can put that in our table as according. So we're going to have to write two different x values in this table because we have two different y values. Or, well, not two different x values. Sorry, that's important to know. Same x value, just two different y values. So let's just write it in. Doesn't matter if you put -2 on the top 4 or the bottom 4. Doesn't matter, as I've said. So now we can kind of see, is this a function? Is this not a function? Or remember, we're already seeing repeat x values. That's already a red flag. Now let's check. Are the y values different? They are. We have two different y values for the same x value, meaning we are not a function. And I know I didn't specify on this one, but we are a function on y equals x squared. But on y squared equals x, we're not a function. We are not a function. Now, how does that look on a graph? Let's take a look. So let's just plot our 3 points. That's all we need for this example. So when x is 0 up here, y is 0. Boom. And this is xy plane. I'm sorry I didn't specify. Xy plane. And then we have these two right here. So when x is 4, y is also is -2 and 2. So we have those 2 points. So let's go to x equals 4, y is both 2 and -2. And the way this graph is shaped, which you don't actually have to know for this problem, but it'll be kind of a smooth curve just like that. But even without that knowledge, you can still figure out if this is a function or not, just off those points. So let's take a look. Let's do our vertical line test. Vertical, and I will write this over and over again because it needs to be in green. It's so important. Vertical line test. So for our x equals 0, we passed the vertical line test. Now let's look at x equals 4. Boom, not a function. Because we've passed through the same x value of x equals 4, and we found 2 different y values. And that's just as the definition says, 2 or more y values or 2 or more outputs for the same input, which is input of x equals 4, or input of 4. And if I draw it as the function, as I just said, which was kind of a smooth curve, is like that, we can see that for every point we do, if we just keep doing vertical lines, just everywhere, we continue to fail the vertical line test for this relation, because we constantly have 2 points touching on every single one of these lines that I just drew, except for x equals 0. But remember, all it takes is one to fail, or all it takes is two dots along one x value, along one vertical line to fail the test. So we can say that y squared equals x is not a function, which we just proved through the table. Which we just proved through the table and the graph. And y equals x squared is a function because although it has repeating y values, they're different x values. And we do pass the vertical line test.